Let's do an introduction to functions and how to find the domain and range of those functions. So the first thing is what a function is. So a function is a relationship where each input has one and only output. The input values are the independent values, otherwise known as the domain of the function. The input values most commonly are known as the x values. So the input can only have one value for each output value, and the output values are as follows. So the output's the dependent values, meaning they depend on what happens with the independent values. And then it also, the output describes the range of the function, and also it represents what the y values are. Alright, so let's say here we have a relationship. 4, 1, 3, 6, 2, 7. This relationship, let's decide if this relationship is a function or not. So we would list the domain. The domain in this are all the x values here. So we have 4, 3, and 2 is the domain, the x values. And then we're going to list the range. The range is 1, 6, and 7. Each x value has a unique y value, meaning that the y values don't share anything in common, or two different y values don't have the same x value, because x can have only one y value. So because the domain and the range are unique like that, we have a function. Let's look at an example where we would not have a function. Alright, so I have this relation here, 4, 3, 6, 2, and then 4, 10. Okay, we have here this 4 goes with 3 and the 4 goes with 10. So my domain here would be 4 and then 6, because 4 happens twice, you don't need to write it twice. The range on this would be 3, 2, and 10. You cannot have more y values than you have x values in the domain or range, because the domain here has two x values, or one x value that has two different y values. This is not a function. Okay. Alright, if you have a graph and you need to tell if it's a function or not, there's a really quick, easy way to see if there's a function or not. And it's by doing a vertical line test. The vertical line test just says if you draw a vertical line anywhere on your graph and it crosses in more than one spot, then there is not a function. So, for example, let's look at this. If I draw a vertical line anywhere on this graph, anywhere, it's only crossing in one spot. So, this right here would be a function. I'm just going to write yes for a function, no for not. If we look at the circle and I draw a vertical line here, it's crossing in two spots. So that would not be a function. This one's a little tricky, so if I draw these vertical lines, it's only crossing in one spot. The only place that it can be somewhat curious is this right here. Because I have an open circle, means cannot equal to, and a closed, it is only crossing in one spot on the actual graph, so that would be a function. Alright, this is a line, so I'm only crossing in one spot, so that would be a function. This one right here, I draw a vertical line here. It's going to cross in 2 spots. So that would not be a function. Now in all the spaces other than this, you're not crossing at all, so that would be okay. However, here you're crossing at infinite spots because we have a vertical line. So this would not be a function. So a function can be represented as f of x here equals some relationship with respect to x. This relationship can be multiple things. So we have f of x, meaning that y is a function of x. So f of x means y is a function of x, and x represents all the independent values, and y represents the dependent values, so that would make sense, that y is a function of what happens with x. Now x is going to have restrictions. Its restrictions would be the domain. So the domain are only the values that x can be equal to. And here we have, there's only 2 types of equations really that we will look at that have a restriction on x. And it's the first one is if I have a rational equation, and the second one is if I have a square root equation. Alright, so to find the domain of x, let's do a problem, or this one right here. It means that the denominator cannot equal x. So in this case, our domain can equal all real numbers except for x cannot be 0. Because if I put 0 in there, then you have 0 in the denominator, and we all know that you cannot do that. If you were to write that as interval notation, that would be negative infinity to 0, union 0 to infinity. So that would be the restriction in that domain. If we look at a square root, we know that the domain on this is that x has to be greater than or equal to 0. Because we can't have 0 in the square, or negative number inside the square root. So then if we were to go and write that as interval notation, that would be from 0 to infinity. So that's how you would find the domain if it were inside the function notation of that. And of course, that could alter. So if I had like the square root of x minus 1, then we know that x minus 1 has to be greater than or equal to 0. So x would be greater than or equal to 1. And you could write the interval notation based off of that.